All right, plan for the recording is talk through the chapter 8. I know it says 9, but that was from a previous year. So chapter 8, review worksheet. First question. It's just understanding notation for question number 1. A sub n is an arithmetic sequence. If I ask you to find a sub 35, remember a sequence is individual terms. A series is the sum of those terms. So a sub 35 asks me to find the value of the 35th term. Not a whole lot of calculations. Don't need to write a whole lot. Remember the answers are at the end of the worksheet. Flip it over. You'll see exactly what I just wrote or just said there written. Question 2. S, on the other hand, is the sum. It's a series. So S sub 19 would be finding the sum of the first 19 terms. S sub 19 is finding the sum of the first 19 terms. Okay, again, that's just notation. Now we got to do something. Question 3. Determine whether it's arithmetic, geometric, or neither. Arithmetic has a constant difference. You are adding, and you have to think of it adding, not subtracting. You're adding the same amount every time. Geometric, you are multiplying by the same amount every time. And again, you have to think of it as multiplication, not division. So question 1, looking at 21 to 15, looks like we're subtracting 6. Is that the same from 15 to 9? Are we still subtracting 6? Yep. From 9 to 3? Yep. So my sequence is arithmetic. My constant difference then would be subtracting or adding a negative 6. Okay. Find the next term of the sequence. So if I subtract another 6, I get negative 3. And if we keep doing that, we get a negative 9 and so on. Okay. Question 4. 640 minus 160 gives me 480. Minus 160 does not give me 360. Not arithmetic. So 480 divided by 640 would be 0.75. Let's double check. 360 divided by 480 equals 0.75. 270 divided by 360 equals 0.75. So my term or my sequence is geometric. Why? Because the constant ratio, there is a constant ratio. What is that R value? 0.75. You could say 3/4. You could put 480 divided by 640, and you could have reduced it down to what, 160, and it goes into both 3 and 4 times. That's fine too. Fraction, decimal, either way is fine. As long as your decimal comes out to be a nice roundable decimal, then you're good. Okay. So just make sure you have the good R. All right, so the next thing then, this is geometric because it has a constant ratio. And my next term would be taking 0.75, multiplying it by the 270, and I get 202.5. My answer key, I gave you 2 next terms, but it just says on the next term. Okay. Question 5. Find the 16th term of the sequence. First question. Is it arithmetic? Constant difference. Is it geometric? Constant ratio. So negative 9 plus 4 gives me negative 5, plus 4 gives me negative 1. And so my sequence is arithmetic, constant difference of 4. Going to my formula, a sub n equals the first term plus n minus 1 times the difference of 4. We're looking for the 16th term, so a sub 16 would be a negative 9 plus 16 minus 1 times 4. That's 15. 15 times 4 is 60. 60 minus 9 is 51. All right, question 6. Again, first question, arithmetic or geometric? When I look at my terms, I get a negative 36 divided by 9, which is a negative 4. 144 divided by a negative 36, which is a negative 4. And so my r value is a negative 4. So my equation, a sub n, equals first term 9 times r raised to the n minus 1. And in this case is 16. So a sub 16 equals 9 times a negative 4 raised to the 15th power. Grab your calculator, typed it in, and we get the answer in the back. 9, gigantic number, 966, etc. And I will make the assumption you can type that into the calculator. Hopefully that's a good assumption. There's times when I'll type stuff in, like some of the sum stuff, but for, I think 6 is fine. I think you can type it in. All right, question 7. If you did not get question 7, that is understandable. We did not talk about this thing called recursive definition, but I wanted you to see it. Not going to be on the test, but I wanted you to see it. It's not hard to learn, but I think the notation is important to see. So here's what we have. I'm going to write this. I'm not sure we've seen piecewise. I'm going to write this as a piecewise definition. So I'm going to define a sub n using 2 different definitions, or 2 different parts of a definition. So a sub n equals 6 when n equals 1. And a sub n equals 2 times a sub n minus 1 for any value for n that is 2 or higher. What does that mean? So when n is 1, so my first term in my sequence is 6. Right? A sub 1 is 6. But for every term after that, for the second term, the third term, for every term after that, this is my definition. So what does that mean? So if I want to find the second term, my n is a 2. Right? I know my first term. I want to find my second term. So n is a 2. So this subscript n minus 1 becomes a sub 2 minus 1. And a sub 2 minus 1 is just a sub 1. So what this really says, takes 2 times the previous term and then subtract 1. A sub 1 we just said was 6. So a sub 1 is 6. So this is 2 times 6 minus 1, which would be 12. Minus 1 is 11. If I want to find the third term, n is a 3. And 3 minus 1 would be 2. So this says take 2 times the second term and then subtract 1. So do you see how this minus 1 in the subscript tells me look at the term before the one I want? If I want the third term, look at the second term and plug it in. If I want the fourth term, look at the third term and plug it in, and so on. So all this really says is take 2 times the previous term, subtract 1, and that gives me the next term in the sequence. So 2 times 11 is 22, minus 1 would be 21. 2 times 21 minus 1 would be 42, minus 1, which is 41, and so on. That's called a recursive definition. When your definition depends on the terms in the sequence or the terms before it, it's called a recursive definition. Okay, on your calculator, this would be 2 times the answer minus 1, right? So I take 6 times 2 minus 1, I get 11. Take 2 times 11 minus 1, I get 21. And just keep doing the previous answer times 2 minus 1. Your calculator is programmed in recursive mode or in recursive notation. Okay, again, not on the test, but I think it's important for you to see it. All right, question 8 is on the test. Rewrite each series in sigma notation. Remember what this summation or this sigma means. It means to add up all the numbers from I equal 1 to I equal n, from the first term to whatever term we want to end at. And what goes here, a series is the sum of a sequence. So this says add up. What am I adding up? My sequence formula, because that's the definition of a series, the sum of a sequence. So when I'm writing it in sigma notation, I'm going to go I equal 1 to n, which we'll talk about later because I don't know it. And then we're going to plug in, we're going to find that n value and then solve. Right, so what goes here then, I'm going to use my sequence formula. Remember that is a sub n times a1, or equals a1. So first term is 12. Oh, sorry. It is geometric arithmetic. Before I jump into the formula, I notice it goes up by 9 every time, so it's arithmetic. Okay, so I'm using the arithmetic sequence formula here. 12 plus n minus 1 times d, and d looks like 9. So I have everything I need except for n. So go back to what we did on some of the other worksheets. I'm going to call my last term 147. My first term is 12. My number of terms I don't know. Common difference is 9. And do my algebra skills and solve that thing. Subtract 12. Remember we talked about this will always divide out, so I would never is probably a strong word, rarely, but probably never distribute that 9. I'm just going to divide by 9. And what is that, 15? Add, and I get 16. Number of terms, 16. Okay, rewrite each series in sigma notation, done. And find its sum. So now I switch gears and I go to the sum formula or the series formula. I don't want to have to add 12 plus 21 plus 30, etc. I'm going to use my formula. Formula says take the first term, right? 12 plus the, I guess slide it over, sorry. Let's start from the beginning. How about n times the first term, which was 12, plus the last term, which is 147, divided by 2. And this 16 can go on front. This 16 can go on top. Either one is fine. Final answer, 1,272. So here's my two answers. Sigma notation and S of 16 is 1272. Okay, same, repeat the process. I equal 1 to something, I don't know the something, and then my first term, this is geometric because we're multiplying by 3, so my r value is 3 to the n minus 1. I know everything I need to know except for n. In class, we talked about how to find n using logarithms. We're just going to go old school, basic, and we're just going to count. So I got 12 times 3 times 3 times 3 and so on, and we're just going to count the numbers. So 12 times 3 is 36, and here's the recursive definition part. I'm going to times it by 3. And now all I have to do is just keep hitting enter because it has a definition. So there's my 12 is my first term, 36 is my second term, 108 is my third term, fourth, fifth, sixth, seventh term. So 8748 is the seventh term in my sequence. Okay, get rid of that. So this would be 7. And we're done. No, we're not. Find the sum. S sub 7 equals first term 12 times 1 minus r, which is 3. 1 minus 3 raised to the n power, which we just said was 7, all over 1 minus r, which was 3. Okay, I am going to type that into the calculator because, at least for some of us, that was a difficult thing to do. So I'm going to go 12. Using the big calculator, I would probably do the whole entire thing at one time. Yeah, this one has a nice little shortcut. I can make it a big fraction bar and type it just like we can, but on the 84s, I don't think that's an option, so I'll do it long ways. So 12, parentheses, 1 minus 3 raised to the 7th power. Make sure that 3 is being raised to 7th. Make sure the x1 is not on the outside of the parentheses. I'm going to move over to get outside the parentheses, divided by parentheses 1 minus 3. And if I didn't want to do that, then I would just take the 1 minus 3 and do it in my head. and get a -2. Either way. Final answer, 13,116. Make sure you can type it into the correct calculator correctly, whichever way you do it. Not sure why I did that. Okay. All right. 8 and 9, guaranteed. You'll see that on the test. Just plug in 1, 2, 3, 4, etc. So a sub 1, whoa, where'd that come from? A sub 1 equals 2 to the first power minus 5, which would be a -3. A sub 2 equals 2 raised to the second power minus 5, which is a -1. A sub 3, and so on. What is that? 8, 3. A sub 4, 16 minus is 11. A sub 5, 32 minus 5, which would be 27. And we're done. There's my first 5 terms. It's just a matter of plugging in 1, 2, 3, 4, 5 for n. Okay, that one's not too bad. All right, expand the series. Simply means add up all the numbers from 1 to 5. So k, I, k, same thing. So -1 raised to the first power times 7 minus 1 times 1. Where am I getting the 1? K equals 1. Start with the first term, plug in 1 for every single k value, and work it out. -1 times 6 is a -6 times 1 is a -6. Repeat the process. -1 to the second power. 7 minus 2 times 2. I'm putting a 2 in for every single k. Why am I doing that? Because I'm counting from 1 to 5. And then I'm going to put in a 3. And then I'm going to put in a 4. And so on. Okay, so -1 squared is a positive 1. 7 minus 2 is a positive 5. Times 2 is a positive 10. Plugging in plugging in 3 gives me a -1. 7 minus 3 is 4. 4 times 3 is 12. Times a -1 is a -12. So my expansion is a -6 plus 10 minus 12. Plug in 4. -1 to the fourth. 7 minus 4 times 4. This becomes 3 times 4 times a positive 1, because a negative times a negative 4 times will be a positive 12. And the last one, -1 to the fifth. 7 minus 5 times 5. This becomes 2 times 5, which is 10, times a -1, which is a -10. Expand the series. Done. I went one more step and I just evaluated it. This and this cancel. This and this cancel. Evaluating it would be a -6, but they asked me to expand, so that's my answer. All right. Question 12. Now we find the sum. Notice 1 to infinity. So now we're doing the infinite sum. So s sub infinity is a sub 1 divided by 1 minus r. That's it. So what's my first term? First term, plug in 1 for n. Three-fifths to the first power is 3/5. Times 4 would be 12/5. Right? This is 4 over 1. 4 times 3 is 12. 1 times 5 is 5. Okay. What is r? R is the base of my exponent. Right? Back in our definition of a geometric series sequence. The r value is the base. I get it. That's n minus 1. The one we have is just n, but the base is still my r value. So r looks like 3/5. So this becomes 1 minus 3/5. So let's do a little fraction work. Stay away from them calculators. 1/5 or 1 minus 3/5. This becomes 5/5. So 1/5 minus 3/5. Sorry, 1 minus 3/5 is 2/5. To divide by a fraction, we multiply by the reciprocal. 5s go away. That reduces to 1 and 6. My answer is 6. Okay. Find the sum, 6. Let me get rid of that mess because it went way over into my other problem. All right, find the sum. Same idea, but now it's not infinite. Now we're doing the first 9 terms. What kind of sequence is that? Right, sum of a sequence. This one was geometric because it's in the right form. It's multiplication with an exponent and so on. And this one is arithmetic. Why? It's in the right form of arithmetic. Okay, so I'm using S sub 9. Arithmetic sequence formula, series formula is this guy here. First term, nope, this one here. Number of terms, first term plus last term, okay? First term, plug in 1. Got you gun shy, you don't want to think it's the 4. It is the 4, but let's just double check. Plug in 1. 1 minus 1 is 0. 0 times 3 is 0 plus 4. My first term is 4. Nope. Did that last time, didn't I? My number of terms is 9. My first term is 4. My 9th term, plug in 9. 9 minus 1 is 8. 8 times 3 is 24. 24 plus 4 is 28. Divided by 2. I get it in the formula. I have the 9 out in front. It doesn't matter. Up top, out in front. I think it's probably easier up on top, my opinion. Grab a calculator. Type in 9 times 32 and divided by 2. Final answer, 344. Okay. Use a given series to answer the following questions. Does a series converge or diverge? Converge, r is less than 1. Diverge, r is greater than 1. Technically, and greater than 0. Okay, so what's my r value? That'll tell me whether it converges or diverges. Does it come to a single number, or does it go to infinity? Or does it just keep getting bigger? That's the question. So looking at this, we have to look at whether the r value is positive or less than 1 or greater than 1. All right, so now we have to decide what is r. So we'll grab our calculators and take the second term divided by the first term. So 348 divided by, I lost my number, 464. I'm going to get 0.75 or 3/4. Now go to the next one. Is it the same? Is 261 divided by 348 the same 3/4? Yep. So I know my r value is less than 1, so it converges. So I'd write up here, it converges. Why? Justify reasoning, r is less than 1. Okay? S of 9. S sub 9, I'm going to my series formula and plugging in the information. It is a geometric, so my first term we have is 464. 1 minus r. And we just found that r is 0.75 or 3/4. I'm going to use a decimal. Raised to the nth power, which we know is 9. All over 1 minus r, which is 0.75. Grabbing our calculator, typing that mess into the calculator. We get 464. Sorry, I was getting my right numbers. Trying to remember everything. There we go. All right, so we got 464. Parentheses 1 minus 0.75 raised to the 9th power. Jump outside the parentheses. Divided by 1 minus, nope. Be careful, parentheses, 1 minus 0.75. And if you know what 1 minus 0.75 in your head is, which hopefully we do, is 0.25, you can just type in 0.25 and not have to have the parentheses and all that good stuff. Answer 1,700, etc., which is what's on the answer key. Okay, S sub infinity. Simply a sub 1 divided by 1 minus r. First term, 464. 1 minus 0.75 is 0.25. So I have 464. I'm just going to show you one more quick thing or way of thinking about it. Dividing by a quarter is the same thing as multiplying by 4. So you can also just do that. Whatever works, whatever you like. And I get 1856. You can do 464 divided by 0.25 or recognize its multiplication. Either way. R value, a sub 1. That's all I need for the infinite sum. The sum of an infinite series is simply a sub 1 divided by 1 minus r. And we talked about in class why that is, so I'm not going to go through it here, but that's all it is. Okay. My guess is some of us missed this one because of the timesing by 2 part. A ball is tossed vertically. Here's the ground. Ball is tossed vertically. It goes up and it comes back down. The ball is thrown vertically to a height of 210, which means it went up 210 and it came back down 210. So that's why at the end of my answer, I multiply it by 2 because it goes both up and down. Okay, so ignore that for a second. I'm just going to do the up parts and I'll times it by 2. The next bounce is 4/7 of that. And I want to know the total distance the ball travels before coming to rest. Total distance the ball travels would be an infinite number of bounces. So all I need is my first term divided by 1 minus r. And r, we are told, is 4/7 times the previous height. My recursive definition. So then I take my calculator and I'm going to go ahead and do it just like that so you can see how I need the parentheses. And I'm going to go 210 divided by parentheses 1 minus 4/7. Get out of my parentheses, hit equal, and I get 490. That is the total vertical distance going up, but we go up and down. So we times it by 2, and we get a total distance traveled of 980 feet. Okay. Landlord sets a charge, $20 for the first late payment, $6 increase for every payment after that. Arithmetic or geometric? Arithmetic. The charge increases by 6. It's adding 6 every time. So my a sub 9, ninth late payment, is going to be the first term plus 9n minus 1 times the difference is 6. Every late fee is $6 more than the one before it. Work it out. 8 times 6 is 48 times, or a plus 20. $68 for the 9th late fee. If this tenant pays all 9 late fees, how much will they pay? So this is going to be number of terms, right? 9 times the first term, which we said was 20, plus the 9th term, which we said was 68, divided by 2. And when you type that into the calculator and work it out, at least I got 396. And I'm assuming you can do that. Good units would be dollars. Okay, number 17. First minute, submarine can dive 240 feet. Second minute, they can dive 180 feet. Third minute, 135 feet, and so on. Why are they diving less each time? Whatever, pressure, etc. So they can't dive as fast every minute as they get deeper. So what's my R value? Is this arithmetic or is it geometric? So 180 divided by 240 gives me 0.75. 135 divided by 180 gives me 0.75. So it is geometric. My R value, 0.75. How deep can the submarine dive on the 10th minute? Sequence or series? Sequence. You're looking for an individual minute. How deep will the dive be after 7 minutes total? Series. On the 10th minute, during that 9th to 10th minute, during that 1 minute interval, how far will the submarine dive? That's what we're looking for. As you can tell, the bell just rang. All right, I'm gonna hit pause and come back. Okay, so we decided this is a sequence because we're looking for on the 10th minute. And so looking at my geometric sequence formula, I have a sub n equals the first term, 240. We said our R value was 180 divided by 240, which is 0.75 raised to the n minus 1. And we're looking for the 10th minute. So n is 10. Both ends. And again, I would do this one in my head. 10 minus 1 is 9, so you don't have to have the parentheses. Grab a calculator. Type that into your calculator, and I got 18.02. Correct units would be feet. So during the 10th minute, the submarine can dive 18.02 feet. Question B, how deep will the submarine be after 7 minutes? So now we're not looking for the 7th minute. We're looking for the sum of the first 7 minutes. We're doing a series formula. S sub 7. Excuse me. Number of terms, 7. It's, oh no, sorry. Wrong formula. It's geometric. So the first term, which is 240, times 1 minus r, which we said was 0.75, raised to the n power, which we are told is 7, all over 1 minus 0.75. Grab a calculator, type that mess in. I assume you can type that into the calculator, and I get 831 feet, 831.85 feet. So after a total of 7 minutes, the submarine will be 831.85 feet deep. Now, if this continued forever, so S sub infinity, how deep can the submarine dive? 240 divided by 1 minus 0.75. Grab a calculator, type it in, and you should get 960 feet. After 7 minutes, it's at 831. From there to infinity, it only can go another 130 feet deep, because every minute it only can dive 75% of what it dove the minute before. So eventually it's going to quit diving. Well, mathematically it's not, but realistically it is. All right, question 18 is more of a thinking question. There's no formula to type in. It's just looking at that sequence, looking at that series. What's my sum? Here's what I noticed. We have patterns. If I add the first to the last term, I get 100. If I add the second term to the second to the last term, I get negative 100. And that pattern continues. This number right here is going to be a 97, plus 3 is 100, and it just keeps oscillating back and forth between positive 100 and negative 100. Except for there's one number right in the middle that doesn't have a pair to come up with positive 100 or negative 100. All these other ones are going to go away. So my middle number would be 50, right? There's not a pair that goes with 50. Every other number is going to have a pair. So is the 50 positive or is it negative? Looking at all my even numbers, I notice that all my even numbers are negative, and so it's going to be negative 50. So every single pair will cancel except for that negative 50, and that's my sum. Again, no formula, just a little bit of thinking. And that is it. That's the review. Sorry, I got interrupted about 3 times during that, so hopefully it wasn't too disjointed, but I think you should be good to go. If you have questions, make sure you pop in, and we'll see you later.